Hello everyone. In this video I will demonstrate how to perform an independent samples t-test in SPSS. So let's have a look at the example. An experiment was carried out to investigate the effect of dietary supplement on various aspects of cognitive performance. 16 participants took part in the study, with each participant being allocated to a control with no supplement or a treatment with supplement condition. It was hypothesized that there will be a difference between the two groups in their cognitive performance. So, first you need to identify independent and dependent variable. So in this task, the independent variable is a group where participants were allocated with levels of control or treatment, and the dependent variable is cognitive performance. The next important thing to identify is it between or within participants' design. In here, it states that 16 participants took part in the study, and with 8 participants in the control group and 8 participants in the treatment group. So we know that this is a between participants design, and therefore we perform an independent sample t-test to analyze the data. The next thing you need to determine is whether your hypothesis is directional or non-directional. In here, it states that there will be a difference between the two groups in their cognitive performance. It doesn't state you which group will perform better or which group will perform worse, which one will score higher, which one will score lower. So it just tells you that there will be a difference, but it doesn't tell you which way, and therefore it's a non-directional hypothesis. And for the non-directional hypothesis, we'll need to run a two-tailed test. So, entering the data in SPSS, because this is a between participants design, firstly we need to code a control and treatment groups, which basically you record the variable group and you give it levels, control, or treatment. So I already prepared the SPSS data file and we can have a look how it looks. So I'm in a variable view and I enter participant number because I want to make sure I don't make mistakes in data entry, so I do enter 16 participants per se. Then I have a condition or group, and I coded it as 1 was a control and 2 is a treatment. Okay, and then cognitive performance. So our condition is a nominal group because participants were either in one group or the other group. And our cognitive performance is a scale because let's say it's ranged from 1 to 30, and the higher you score, the better your cognitive performance is. So let's have a look how the data looks like. So I'm taking 16 participants. I'm giving which conditions they came from and what they score in their cognitive performance test. So if we look at in relation to our data, here we go. Participant 1, let's say, was given a number 1, they were in condition 1 and they scored 18. So that was the data for this value. The next one, if we want to enter value 19, we have participant 2 was allocated number 2. They were in a fast condition, they were in a control, and they scored 19 in the performance. If you code your variables appropriately, and here is an option in SPSS when you can swap the values for the labels, and if I'll press this button, it tells me whether they're in a control or treatment group. It basically gives me the labels for my values 1 and 2 that I assigned in the variable view. So after the data is entered, as usually for all the tests, we need to calculate mean and standard deviation, basically calculating descriptive statistics. T-test does that automatically for you, so you don't have to run an extra analysis calculating means and standard deviations for your variables. So as with all tests, they're in Analyze menu. So we go to Analyze, and the t-test is test of mean differences. So we go to Compare Means, and we know that it's between participants design, therefore we need to run independent samples t-test. So let's choose it. And there we go. Our participants' cognition and cognitive performance. Test variables or variable is the dependent variable you have. So our dependent variable is cognitive performance. So we'll put the cognitive performance in a test variables. Our independent variable is the condition, and that is a grouping variable. So highlight condition and press on the arrow to put it into the grouping variable. After that, before SPSS allows you to run the analysis, you need to define groups. So basically, we had 1 and 2 in our groups. There we go. So group 1 was 1 and group 2 was 2. Also, if you have a long data set or a big data set, and let's say you want to analyze, for example, people low on anxiety and high on anxiety and how they let's say how that affects their academic performance, you can put the cutoff point and it will split your groups. So if you choose, let's say, median split, it will split it into groups of same size. You may also have a cutoff point split, which, for instance, when you classify people as low on anxiety and when you classify people as high on anxiety. However, it doesn't apply to this task. In here we simply have groups 1 and 2. So press continue. Options, there is nothing you need to play around with. Everything is selected by default for you. And we now press OK. So here is our SPSS output, and we have group statistics. So we have control group with 8 participants, and this is their mean for cognitive performance with a standard deviation of 3.3. And then we have a treatment condition with 8 participants and they mean of 18.6 for cognitive performance and standard deviation of 4.9. The next table is independent sample statistics, and what we have is the Levine's test of equality of variance. This test is important. And then we have a t-test result. So, why Levine's test of equality of variances is important is because one of the assumptions for running a t-test is that you need to have equal variances in 2 groups. Equality of variances, also referred to as homogeneity of variances. Basically what that test tests is whether distribution in one variable is in one group is significantly different to another group. And here we see that it's non-significant, which means that their variances are equal, which means we satisfy the Levine's test of equality of variances. Because equality of variances is assumed, we read the output from the first row with the equality of variances assumed. So here we have our t-test statistics, our degrees of freedom, basically the distribution for the 14 degrees of freedom for our t-value to determine if it's significant or not. And here we have whether our t-value is significant for two-tailed test. If you'll remember, our hypothesis predicted that there will be a difference between 2 groups in their cognitive performance, and this was a non-directional hypothesis, and therefore we're using a two-tailed test. So we have nothing to do, we don't have to do anything extra with this significance value. So 0.084 is non-significant, and therefore there is no significant difference in cognitive performance between participants who were in a control and who were in a treatment condition. If you want to interpret it in the forms of the hypothesis, you can simply say that there was no significant difference between the 2 groups in their cognitive performance. So significant difference in their cognitive performance. So you can use, and it's actually less confusing if you would use the actual hypothesis when you describe the results of your study. Okay, another thing you may find useful is confidence interval for the differences. Some people ask for confidence intervals, others don't ask. It's entirely up to you if you want to report them or not, but this is where you find confidence intervals, lower and upper bound. That's it.